Hey, Mr. Allred here, and we are solving quadratic equations, and we're solving them by factoring right now, or at least that's how we're doing our examples. And I have two examples here that are by factoring. They're not really trinomials, so the ax squared plus bx plus c can be done, or they could be done a little bit quicker if you notice what's going on with them. So let's get into them. The first one here, A. 3x squared plus 21x equals 0. So there's an x squared term, there's an x term, but there's no c term. So there's a little bit less terms. So in this case, maybe we can factor it just by pulling out a common term. And if you look at the two terms, 3x squared plus 21x, you'll notice you can pull out a 3x, and that would leave you with x plus 7. Well, we just factored this thing, and the two things multiplied together to give us 0. We factored it into 3x, and we factored it into x plus 7, and those two things are multiplied to give us 0. So instead of going through the long process, which will still work if we let a be 3, B be 21, and C be 0, but we're never really guaranteed anything's going to factor. We can just pull out a common term. So we get two little equations. 3x equals 0, x plus 7 equals 0. And some people make a mistake here, but if you take 3x equals 0 and divide both sides by 3, you get x equals 0 as one answer, and that is an answer. You could go back and plug it in and check it. The other one gives me x equals negative 7 when I move the 7 over. Once again, you could check that. So that was a little bit quicker if you're missing a term or you notice that you can factor it a little bit differently. Okay, so we still used factoring, but we didn't use the AC method that took up half our page. Okay. The second one here, 9x squared minus 16 equals 0. Once again, there's a term missing. I don't say missing, but there's only two terms. There's the ax squared, and then there's the c term. There's no b term, so there's nothing in the middle. But what you may notice is the first term is a perfect square, and the second term is a perfect square. So we might be able to rewrite this as a difference of squares. And if we do, then we'll know how to factor it. So the first one is 9x squared can be written as 3x times 3x. 16 can be written as 4 times 4. So keep in mind that this right here is going to be our A and this is going to be our B in the difference of squares. Ooh, I don't know what the B was for. Difference of squares. And to remind you what that formula was, it was a squared minus b squared equals a plus b times a minus b. So that's just going to help us factor the left-hand side. So down here the two factors will be 3x plus 4 if I follow the template I gave, and 3x minus 4. And as far as the equation goes, that'll be equal to 0. So a little bit different method, but I got the two things multiplied together to give me 0. 3x plus 4 and 3x minus 4. So I have two simple equations. I'm going to get x by itself in both. So the first one will be x equals negative 4/3. The second one will be x equals positive 4/3. So we have many methods of factoring depending on what we've got. So I don't want to get you pigeonholed into using the long method every time. That long method would have worked on both of these if you identified A, B, and C correctly. But once again, let me state that everything does not factor, so you can't count on factoring working for every problem, as we'll see in coming videos.